All right, let's get started. Good afternoon, everyone, and thank you for joining today's NIBA webinar on conveyor belts in the modern distribution center. We're pleased to see so many people registered and attending this session. And before I introduce our panelists today, I'd like to go over a couple housekeeping items. First, please note we'll take questions, but we'll take all of the questions at the end of the presentation. There is a Q&A button at the bottom of your screen. Feel free to use that to submit your questions or type them in the chat. But like I mentioned a moment ago, we'll get all those questions to our panelists at the end of today's session. I also wanted to give everyone a short update on some NIBA related items. I know everyone is dealing with COVID-19, and we're optimistic that things will come back to normal sooner rather than later. So looking ahead to September, I just wanted to remind everyone that we have opened the registration for our NIBA annual meeting in Austin, Texas, with some risk-free policies. So no pressure to commit before you're ready to, but I wanted to let everyone know that you can go to NIBA.org and find that information under our events and the conference page. And hopefully we'll see many of you in Austin, Texas in the middle of September. Also, I wanted to just make everyone aware that, NIBA webinars, are available to any active member companies. Obviously, we want to keep these as generic as possible, considering that NIBA promotes the whole industry. So, feel free to get in touch with myself, Michael Battaglia, the executive director, or any of our staff if there's an application-based topic that you would be interested in presenting to the community. And also, if you missed any of our previous webinars, please note we are recording them and posting them to the website after they're completed. This webinar will be recorded, and we should be able to get it up within a day or two at the most. So without further ado, I want to introduce our panelists. Today's webinar will give an overview of the two primary types of DC system designs and an analysis of the individual belt types found on each machine. We have Rob May, who's the Business Development Manager, Logistics for the NIDA Corporation of America. May has been with NCA's manufacturing facility based in Georgia for 7 years. He works with distribution and OEM customers. We're also pleased to have Kim Millsaps, NCA President. Kim has been with the company for 33 years and is a key member of the NIDA logistics and converting industry programs. A Navy veteran with 6 years of service during the Vietnam War, Millsaps was named president of NCA in 2008. During his tenure as president, NCA has become the company's global business unit leader in the conveyor and power transmission division sales growth. I'll turn it over to Kim to get us started.
Thank you. I wanted to welcome all in attendance to this overview of the logistics/e-commerce distribution center conveyor industry. Our goal today is to familiarize all with the names of conveyor systems and the subset of systems that are used in different applications in the processing centers. Understanding these conveyor application terminologies/names helps greatly when calling on maintenance or reliability engineers at plant level. So that is a key to take some time to try to really understand the applications the next time you're going to be trying to penetrate into a location. With that being said, I'll turn it over to Rob.
Sounds great, and welcome everybody. And before I get into the actual presentation, a little quick note. We had a conference call with Michael last week to set up the technical aspects of hosting this webinar. And one of his questions was, do you want a little video of yourselves doing this presentation? And the official position was that we thought that would take away from the slides. But in actual reality, I was dead set against it because I don't look like that gentleman anymore. This quarantining period has been difficult, with the haircut, and I had a big beard yesterday. So I'm trying to get back on track and figure out how I can have a haircut during this social quarantining time. But hope everybody's staying safe out there during this crazy period. But one of the reasons that I'm excited to be here today, obviously, is this represents probably the fastest growing business segment in our industry. So it's a real focus for us, and we hope you get a few things out of this. If it's not a focus for your organization or your team, we definitely think that this is something that you should look at, because with the growth in the industry, there's a lot of business to be had for all of us. So there's a number of different ways that belting will improve distribution center efficiency. But generally speaking, belts are used to move product through a DC. So either from receiving to shipping or storage to shipping. And there's many different applications within a distribution center as well. So it's important that each individual belt is engineered specifically for each application. And that's what we're going to go over in this presentation. So speed and accuracy are very important in distribution centers. So again, you need a belt that's going to be able to handle those requirements and match the performance requirements. So some of the applications that we'll touch on include gappers, incline decline conveyors. Obviously, the most important thing there is, coefficient of friction. You don't want those packages sliding down the inclines or declines. We'll touch on sortation lines. Obviously, aramid fabric and aramid cord works best for that application because of the low stretch of the material. And you also have very long runs on those applications. So it's important to use the right belt for the right application. So touching on gappers. Gappers essentially are just a series of short elastic belts that run at different speeds to control the gap between the boxes. So this is important, obviously, because they're trying to read, proper barcode reading. So these motorized drive rollers or MDR sections typically are no more than about 2 meters in length, so about 4 meters in belt length. But the important thing to note there is they can run from essentially a start to stop from 0 to 600 feet per minute. So speed is a big deal in these applications. So the goal really of any manufacturer in the industry really needs to be sort of to reduce the overall cost of ownership and to prevent problems. You want to be a problem solver. And so in order to do that, you have to be focused on things like product positioning, tracking problems, intermittent slipping, cracking. So in other words, focus on what's the biggest problem at a distribution center. And once you're able to go in there and do a little bit of engineering work and solve that problem, that's really going to open the door for you at that location for other applications. And then a lot of times, individual distribution centers won't realize they have a problem. So you have to have trained logistics specialists, people with experience, so that they can go out there and solve those issues.
In the new belt designs used to upgrade older systems is also a very important target. What happens there is you change the old styles of belts over to the current designs to give you the better coefficient of frictions and also the difference in the splicing technology, greatly reducing downtime on the older systems. And this is a key to success in this industry.
So aramid cord belts and finger splice elastic belts. This has represented a large growth area for us recently. We see that trend continuing, obviously, as these technologies are much better at solving some of those issues that traditional belts have not, and traditional belts have some problems for these applications. So aramid cord belts with polyurethane encapsulation. So aramid cords, another manufacturer, calls that Kevlar. It's ideal for long run applications because it doesn't stretch. So because it doesn't stretch, it has obviously a much longer life characteristics than what it replaces. And what does it replace? Typically lace belts. So the problem with those belts that are laced is typically you'll get stretch, possibly the lacing comes out, and then what does the maintenance crew have to do? They have to go back in, they have to resplice, shorten the belt, relace the belt. So obviously that increases downtime quite a bit. The other thing that's very important to remember is that these should be encapsulated. You don't want basically the fabric layer or the cords to be exposed at the edges of the belt. If anybody's seen a live roller drive belt, for instance, that's got an exposed fabric layer over time, that'll get wound up on the side of the belt and it looks basically like a cobweb, and you'll have this big cobweb running down the line. And that can obviously get caught up in bearings or in rollers and cause a whole slew of problems. And obviously some of these belts have V-guides like the one in the picture there, but some are flat as well. So a couple specific applications for these aramid cord belts, sortation and strip sort conveyors, so narrow belt strip sorters. So typically narrow belt strip sorters are a series of about 6 to 8 belts across. They're basically designed to move the boxes down the line to sort it, and can be left or right, can be one direction, but sort it off the line, 45 degrees, 90 degrees, just depends on the OEM and the application. They're usually about 30 millimeters wide, and the thing with these systems is the minimum length really out there is about 100 feet. So these systems can be 300 feet. Once you find these systems, it's really important to focus on replacing some of those hook belts. And then live roller applications. So, again, these systems are the same as the narrow belt strip sorters. They can be, 300, 400, 500 feet of belt. So the aramid cord is really key here because it doesn't stretch. And obviously it solves a lot of problems, which decreases downtime. And of course, these can have a lot of different surfaces. You can have a fabric bottoms, you can have rubber covers, just depending on the OEM and the equipment design. And what's important to realize there, obviously, is you can include a Dutchman on some of those longer runs. And so that'll allow you to use up some of your remnant stock that you might have sitting out there on your shelf. So in terms of tooling, here in this picture, you'll see a couple different cutters and then a press in the middle. We've got 2 presetters as well, one with a V-guide, one that's flat. But what's important is that, everybody should have a set of tools, whether your distribution partners, your manufacturers. You can use these on the shop floor, but you can also use these in the field. And it's important that they be lightweight enough that you can, install a belt, because oftentimes, these live roller systems are 20, 30, 40 feet in the air. So you're doing this on a scissor lift. So a water-cooled press really isn't an option at that point. And it's also important to have these because one of the objections we get is, well, we don't want to buy a set of tools. So if you have a set of tools, you can go into that individual location and install the first belt for them so that they can see the performance benefits, and then they can realize that they're going to spend less over the lifetime of the belt, which will more than offset the cost of the tools. So modern DCs and elastic type belts. So this is a really fast growing segment. Elastic belts are obviously replacing some of those, are used on MDR and gapper belts. And they're replacing the belts that are laced. They're running at higher speeds, up to 600 feet per minute. Obviously a lot of different cover types available, a lot of different materials. There's urethane, there's PVC belts, there's flat styles, there's ribbed like the one in the picture. There's also little mini rough top belts as well. They're designed up to 10% elongation capacity, but typically, your installed tension is going to be around 2 to 3%. So logistics applications, onto some specific applications at distribution centers. So there's a couple different types of sortation systems, generally speaking. There's your linear type and there's your circular sortation type. Obviously, linear are just straight, and circular are, in a circular pattern. But some of the different types of linear systems, it can be like a shoe sorter or a narrow belt strip sorter. And we've touched a little bit on the narrow belt strip sorter, but a shoe sorter is typically chain driven, so there's not belts on a shoe sorter. But it's important that your salesmen and your staff know what a shoe sorter is so that it gives those individual maintenance managers at a distribution center confidence that you know what you're talking about. And then, of course, there's circular systems. Cross belt sorters are one of the most popular, but there's also tilt tray sorter systems. And obviously, the tilt trays don't have belts. But with the cross belt sorters, they're basically running in both directions, the belts, and perpendicular to the flow of the system. And tilt tray does the same thing, obviously, just with a tray, and a tray drops down during the sortation process.
It's important to note that the large linear and circular sortation systems at the plant location, usually they're in a building that's 100,000 square feet to up to 500,000 square feet. They're huge systems, and everybody's driven by Amazons and also by Walmarts and know how big those are. But I would like for each of you to take some time, if you can, to write down this name and go to YouTube and take a look at micro fulfillment centers. Micro fulfillment centers. These are systems that are just being introduced for the grocery industry and retail parts like automotive industry, where they don't have a big footprint, but they want to be able to sort and they want to be able to pick and pull efficiently with barcoding. And these are totally automated systems that are belt-rich environments. And there's several YouTube videos out there that show different manufacturers. But it's pretty interesting to see that you can put these in a location that's even under 1,000 square feet to 5,000 square feet. And certain stores in the big cities like New York, Chicago, LA, they're already in the large stores like Targets and Walmarts and other places. They're actually putting tents in the parking lots or building a new structure. They usually always have an extra amount of parking in those areas and outside of the big cities. So these things can be installed in 90 days, and these people can be up and running. And this is the new future direction of grocery pick and pull and pickup in a short period of time.
So touching on different components of the linear sortation system, obviously you have your merger and your induction system, entering boxes, totes, packages into the line. You have your sorter, the main unit doing the sortation. You have your takeaway, obviously moving boxes off the sortation line. And then you've got your control system. And control system typically is dealing with things like your warehouse management system and your warehouse control system. Warehouse WMS, warehouse management system, mainly sort of a 30,000-foot view controlling the whole entire operation of the distribution center. But warehouse control systems really getting down to the actual lines and controlling the actual lines that are doing the work at the distribution center. And then now touching on the components of a circular system. Obviously, you've got your feeding in, your merging into the system. Can include measuring, preparation. There you're lining the boxes, gapping, merging, accumulation, or slug belts. You've got identification as well. So boxes obviously are going to be scanned. And based off this information, then the sortation system knows where to deliver them or sort them to. Then distribution, the actual sorter. And then discharge, where packages are coming off the sortation line. And again, this whole system being controlled by the WMS or WCS systems. So now just going over the actual overview of the process overview at a distribution center. The first being the input stage. Telescopic loaders, basically conveyor systems that telescope out into a tractor trailer to aid in unloading of the boxes. And then you've got picking stations as well. And of course, picking stations are going to be involved in all distribution centers, but it's important to note here that they're especially common and well known at places like Amazon. And that's not really a distribution center, that's what a fulfillment center is. So when you order things from Amazon, say like a shaving cream, a box of golf balls, and a telephone, basically an individual is going to go out into that facility, pick those things and put it on the conveyor system, which then goes down through the sortation system and in packaging. That's typically a fulfillment center, whereas a distribution center, think more along the lines of a regional distribution center for a retail chain. So whether they're taking in boxes and then they're sorting boxes and then they're shipping boxes out to individual stores. Merging and gapping. Merging, accumulating, and gapping, basically getting the packages ready to enter the sortation line. And then identification. So you're going to go through checkwares, scales, scanners, takes all the information from the package, the barcodes, the size, the weight, the address, all that stuff, so it can go to the next part of the process.
Let me reemphasize the importance of gapping, acceleration, deceleration. That is how they get the spacing on the boxes so that it can be read by the scanners. And there's so many different types of scanners now for barcoding and other types of coded information. If you don't have the right gap between the box, you don't get a full scan and you don't get a proper location for that box to wind up in. That's a very, very important part of the system. And those belts have to be updated quite often and make sure they're in good shape.
So now the induction to the sorter, basically, obviously, belts entering the sortation line. This can be a single belt, but in some cases it can be, a narrower multi-belts across. Then into the sorter itself, you've got a number of different types of sorters. We've talked about a couple. Obviously, cross belt sorter. You've got your belt diverter, your pop-up sorter, the shoe sorter again that's chain driven, and of course narrow belt strip sorters. And then into the outfeed final stage. Obviously, the deceleration through decline conveyors, then through your outfeed systems, and then back onto the telescopic conveyors, which are going to reload that tractor trailer with the boxes and ready for delivery. And the other thing as well, you know, there's going to be a lot of auxiliary conveyor belt systems throughout the entire distribution center. So you're going to have things like line belts, just standard horizontal PVC conveyor. You've obviously got power turns. They can be both 90 degrees and 180 degrees. You've got your incline decline systems, usually PVC ribbed, but there can be different different cover profiles as well, jink waves, rough tops. And then rat belts is another one. It's a right angle transfer belt. We'll touch on that a little bit as well. But obviously they're moving boxes 90 degrees off one line to another. You can have swan neck conveyors. Basically that's taking a package up and over something. And then obviously pallet shrink wrapping, which shouldn't be forgotten about in the distribution center. So here in the picture, you'll see an example of a narrow belt strip sorter. And basically there's 8 belts across. And that's a very long run, and that's why the Aramid cord is such a good belt for this application. You know, it's efficient belt on roller design. It's very high strength, doesn't stretch, and just really, really works well for that application.
It's important to note that there's still a lot of manufacturers, several, that supply hooked belts into the industry in these applications instead of endless belts. If you come across this, where it is a hook belt, you would be very, very wise to recommend they take a look at the splice belt. We're going to go over the difference in life characteristic here in a little bit, but it's a pretty easy transition to go from a hook belt to a finger splice belt.
And of course, depending on the OEM as well, some of these applications will have a V-guide on the back. Some are straight just flat belt. But that's something that each individual OEM specifies, obviously. So now in the top picture there, you'll see the right angle transfer belt. And one of the things that we see, there's a number of different style of belts that are used in this application. Flat belts with V-guides, timing belts. So there's a lot of different belts that will pull that box 90 degrees off one line to another. Then you can see the pop-up wheel sorter in the bottom picture on that narrow belt strip line. So those wheels will pop up and divert the box 45 degrees. But also in certain circumstances, the wheels are steerable. So the wheels will control the direction of travel that the box takes.
The rat belt, in most applications where you start seeing these in the large DCs, there'll be usually more than 75 to 150 of these in one location. It's a lot of belt. They're narrow, but it's a lot of belt.
So gapping, induction, merge applications. Again, basically cartons are consolidated and moved from the merge area into the induction conveyor, which then proceeds to the sorter. So elastic belts are very common in this area, depending on the OEM, obviously. Also for some induction units, multiple narrow belts are used. Just depends, you know, what they're sorting. Typically, like for instance, if you find a baby clothes manufacturer and they're dealing with lightweight poly bags, they'll use a smaller series of induction belts versus one wide induction belt for moving onto the sortation line. So different parts of the gapping, induction, and merge applications. You know, you have your brake belts, pretty self-explanatory, slowing the box down. You have your metering belts, your segmented belt on roller or SBOR applications. And more what we see is that finger splice elastic belts are used in these areas, you know, replacing the laced and the hook belts. Different cover patterns are available. Some manufacturers and OEMs still use those hooks and laces, which decreases the overall life and performance of the belt. They are easier to install, however, and that's the main objection that you're going to get in the field. And what's interesting, though, is some of the OEMs are working on systems that use an elastic belt that are just as easy to change. So that's a future direction that's going to be taken. And most of these systems are all going to be 4 meters in belt length or less.
The thing to realize is in large processing DCs, it's not uncommon to see literally thousands of these SBOR, motorized drive roller belts in one facility.
Incline-decline conveyor belts. One of the things that's common here is that more and more distribution centers are very, very focused on decibel levels, noise in the distribution center. So the whisper weave fabric back is really, really more and more commonly used for that reason. The other thing that we're starting to see as well is that some manufacturers or some OEMs and end users are pushing for flame retardant specifications. And so we see that really sort of moving forward with a lot of belts in this area. But for incline-decline conveyor, obviously PVC is mostly used, can be ribbed, can be rough top, jink wave, different covers are available. Then onto your telescopic conveyors, usually fabric or smooth top PVC, both used in the unloading and loading of the tractor trailers. And then the palletizer. And as I mentioned before, basically a nylon core belt is often used as a drive belt for the system. It's either going to be controlling the spinning of the pallet that's being shrink wrapped, or it's controlling on top, it's controlling the mechanism that actually shrink wraps the pallet. And so that's something else to be focused on when you're walking through a distribution center. So just a chart that we've put together, and one thing I point out that there's a lot of different applications and a lot of different options that are available. And something like this can help when you're doing a survey. So when you're walking through a distribution center, it's helpful to have something like this so that you don't miss anything as you're doing that survey. It's also great for marketing campaigns. We've used that for our marketing campaigns as well. And then there is one actually here at the bottom. Third one, excuse me.
Third one up.
The live roller conveyor, heavy duty, third one from the bottom. Should also be, a V-guide should be checked on that. So it's something that we have to correct.
Just add a little check mark to the V-guide column that was missed.
Now on to some success stories. And honestly, we're not telling success stories to tell you how great we are. The main reason we're doing this is to give you some ideas on the opportunities that are available, but then also give you some concepts of some of the different objections that you might hear. So we were approached, or we came into contact with the VP of operations of a well-known retail chain who was having some issues with his live roller system at one of his distribution centers. And so after hearing some of the issues that he was having, we recommended, again, this aramid cord polyurethane encapsulated belt, and that would be vulcanized on the system by our team. So basically, after going through that process, our belts after 2 years are still running. And the old belts, he was only getting 4 to 5 weeks. And some of the issues he were having are very common. You know, the lacing was coming out, they were stretching, there was causing a lot of downtime just going back in there and replacing the belts or shortening the belts. So basically, once realizing, you know, that he could get over 2 years with our belt versus 5 weeks with what he was getting before, he started switching out a lot of his other distribution centers, and we became one of his suppliers for that application. So for the narrow belt strip sorter, this was one of the larger distribution centers in the US, and they were having the similar problems with the hook belt that the previous illustration. Basically stretch, the lacing was coming out. And as you can see, it's critical in this application because as the belt stretches, it's going to jump off that track and then go in between the tracks. And of course, there's nothing to keep the belt from falling in under below. And of course, it's very difficult for the maintenance staff to see that when it takes place, so they keep running it, and that can cause belt breakages and a whole lot of problems on the line. And so that's kind of some of the issues they were having. They were constantly in there on a weekly basis, fixing and replacing belts. So we went in and we put on 16 belts on 2 lines over 300 feet. And basically over a year later, they're all still running. So one of the things that I'd mentioned before, but tooling cost. Some individual locations can say, well, I don't want to spend the money on tooling. And I just want to point out, can you imagine if this distribution center had adopted that attitude? So that's something that you have to be focused on, you know, moving forward. And then elastic type, gappers, belt on roller, or SBORs. Basically, a regional distribution center, a large snack food manufacturer, started to have mass failure across the system on their MDR belts. So there's over 3,000 belts in this distribution center, and they're all starting to fail at the splice at the same time. So we went in and basically put on our units, and then 4 years later, they're all still running. So that manufacturer and that distribution center are thrilled with the performance of the product. But what's important to focus on here is twofold. Number one, there was over 3,000 belts in this distribution center, and that's not a large number. You know, that's not uncommon, in other words. So these different distribution centers can offer a really big opportunity for everyone. And the other thing to realize too is when you see a belt that's causing some problems, it's important to do a little bit of engineering work so that you're not replacing the belt with another belt of the same size and the same style, because it could be something of, you know, too much tension on the belt because the belt is too short. So you have to figure out what the problem is, so then you can engineer a solution.
Couple of points here in closing. The year-over-year growth through 2025 in the logistics, e-commerce, warehousing, DC centers is estimated to be 7+% year over year. This year may be a little bit stifled due to what we're going through right now, but this is a global number. This isn't just a regional number. So there's a lot of equipment that's going to be upgraded, that's going to have new systems put in globally. Something else to note, the warranty on these systems, including belts, it varies. Some OEMs have a 1-year warranty from time of installation. Others have 2 years. It's important to find the systems when they're installed by many of these OEMs and start working on the replacement belt business before it runs out of warranty. I highly recommend that. Keep in mind that upgrading systems that use hooked belts or mechanical fasteners, of course, to an endless product is a key to reducing downtime and having a major return on investment improvement in this industry. 25 plus major global OEMs supply systems to these logistic industry end users on a global basis. And they're adding more every day. The OEMs can't keep up with the volume. So a lot of replacement belt business, a lot of OEM business. This is truly, truly a growth industry that everyone needs to pay attention to. Thank you very much.
Thank you.
Great. Thank you, Rob and Kim. If you can hear me, I have a couple questions that I'll tee up from the audience for you. I think you guys are getting your video going.
Yeah.
Excellent. Excellent. So first of all, great job. I thought that was very well done. One of the questions that came in while you were discussing the Aramid cord belts, are there common belt sizes? Do they use more European measurements in millimeters, or do they use inches?
Yeah, it's most of the engineering information that we get, they use metric system when they're putting products in the design phase. However, what makes it ironic is the purchasing departments in a lot of these groups, they switch it back to the English standard, and they start using feet and yards when they're ordering stuff as well as inches. So it's very important that you understand the dynamics of what's going on. But the other thing is, I can give you an example. One of the large OEMs that we know of, in one facility, there would be maybe 220 different sizes of Aramid cord belts that would be put in. That's why when you buy rolls of Aramid cord, they're made up to, they're 100-meter rolls that most of the manufacturers supply, but they can be made longer so you can reduce your drop. And having the equipment available to put it on is important. Now the width is something that can be somewhat known. There's a lot of 30 millimeter, there's a lot of 45 millimeter wide products that are in the field that are both for live roller and for strip belt sorters, which is the truly target-rich environment.
Great. Another question that came in. How often is tracking a cause of belt failure?
Well, depending on, as Rob mentioned, getting the proper length of belt on the system in the beginning and truly understanding how the take-up is in the system. We have seen OEMs who actually have to install double take-ups because the belts are stretching out on the live rollers and also on the strip belt sorters so much that the initial system that they put in, they had to add a duplicate system. Normally, these are the belts that we were mentioning stretch out, and as soon as they stretch out, usually within 4 to 5 weeks, they'll start having failures, either with hook pull through or with the belts just stretching out so much. And some of these belts are made endless from the OEM, but they're using a material that doesn't use Kevlar cord. So they're stretching out immensely, and then they have a tendency to track off, and then they break. You hardly ever see these belts that are that type due to the stretching and tracking issues that last much more than 3 months is the most I've ever seen.
Well, and of course, it's important to remember as well at an individual distribution center, if the line is bowed, if it's being hit by a forklift of some sort, no belt is going to track. So it's important to realize that up front before you install the belt so you can try to fix and get the line as square as possible so that you don't have tracking issues.
And on the proper Kevlar cord belt choice, there's no going back in and retensioning. Once you set up the tension, once you understand the length characteristic and you understand the load characteristic, the speeds, you set it up one time, and normally you don't have to redo the tension ever again.
Great. Another one that came in, is there a typical US, European, or Asian design used in DCs, or is it more or less a present day or progressive engineering trend?
It's a present day progressive, both engineering trend. All the OEMs are trying to outdo the other ones. They're coming up with a lot more robotic fed units, but that still use belts, but at higher speeds. You see a variation of designs, like we were talking about gapper sections. From one OEM, it's complete. You wouldn't even know that it was a gapper section with another OEM, because they may even be doing it on an incline area, where normally the original gappers are all done on a flat area, going from 0 to 600 feet per minute to get that gap in there. So there's a lot of nuances going on with the OEMs to try to outdo one another. And the OEMs that buy these, that set this up, they know the end users are looking for faster, more efficient systems, and that's what they're selling them on.
Great. A couple splice-related questions. The first one, which splicing method is preferred, fasteners or finger splice?
Actually, finger splice is preferred to be used on the initial installation. Like if an OEM is supplying a product into the field and he's going to do what's right for the end user, doing finger splice belts that are put on as the system is built is something that most of the higher end OEMs are doing now. They're only using finger splice belts. They're getting away from hook belts. However, due to the fact that some end users do not like the time it takes to replace an endless belt, they sometimes resort to a finger splice belt as a stopgap measure, a clip belt, mechanical fasten belt to get the system back up and running. This is not recommended at all for the live roller applications or for the strip belt applications, but for the belt on roller, the short center distances, you can get away with that, but you reduce the life characteristic quite a bit. We have one OEM that we know of that has been supplying finger spliced endless belts for 10 years on all their systems. They just introduced one with hooks on it. That's a standard European style one ply with longitudinal grooves, because the customers wanted a belt they could change out faster. So it's back and forth.
Gotcha. Can elastic belts be mechanically spliced effectively?
No.
Okay.
If you don't have the fabric in there, you're going to have what we all call comb through. That happens pretty quick on a stretchy belt. I have seen some people take some lacing and put on some narrow stretch belts that were on 45-degree discharge or input lines, and they'll last for maybe a week, but that's until they can replace them.
Great, thank you. One more related to splice. Do you recommend only one splice on the long strip sorters?
No, we try to work with people and let them know that in all of our testing that we do in our labs, that if you have over a, let's say 20-meter section that you want to splice into one of these belts and have that 20-meter section to use up some of your drop, that's totally acceptable. We haven't seen a change in the life characteristic if the splices are done properly and everything else is listened to. But we don't recommend anything under that. I do know some people that say that 10 meters is acceptable. We recommend 20, but that's just because we have a different set of rules that we go by sometimes.
Great, thank you. So we got two more questions. If anyone else, we have a little bit of time, maybe take a couple more, but one around the Aramid cord belts. Do the Aramid belts require 750 degrees Fahrenheit for joining, similar to the Teflon belts?
No. You're actually, that's a very good question, by the way. You actually are only putting back together the polyurethane carcass of the belt. You're not actually welding back together the cord. Because of this, you use a very long finger that's over 100 millimeters in length. And the urethane encapsulation is all you're melting. So you're usually on that one around, what is the temperature? Is it 200? It's around 200 C.
Gotcha. Okay. One last question here. Looks like we got maybe two more. Do they make tracking idlers for this type of belt, like being used in the heavyweight belts?
Actually, there's an application that is in the live rollers, which is called a skewed conveyor application. And those of you that are aware of what skewing is, it's where they'll take a series of rollers and they'll turn them on an angle so that a box will go to the right or left as it's being taken down a conveyor system, but it's on an angle. When they do that with a Kevlar cord narrow width belt, it has a tendency to push the belt into the framework, and they do use some tracking devices there that are more like, in the paper industry, we always use the name guidler, which is just a stack of bearings on a shaft, and they'll have those on the side to help keep the belt from going into the edges of the metal construction.
Great.
Mike, let me mention this. Tracking these belts, if you have the proper crowning on a system, is not a big problem. You have a very special way that all manufacturers make these belts to where that it will track very, very well under the tension, but you got to have the proper crowning on your pulleys. And anybody can work that through for someone if they're switching systems.
Okay, excellent. Can you dip the elastic belt ends, I believe, in glue or epoxy and let them dry and then use lacing?
I've heard of people that talked about doing that. We have not done that. We're not allowed to do things like that. But it might be something that someone would want to play around with. I like the semi-elastic epoxy idea, but we've never done it. But it sounds like something that somebody should test.
Great. Do you have any recommendations to alleviate dust or dirt buildup or ribbed incline decline belts that sometimes cause problems with plastic totes sliding back?
Yeah, that's got to do with the type of cover that you put on them. Longitudinal groove is the one that we've hit on that does very well with a low durometer. And it'll actually kind of clean itself when it goes around the pulley. It'll kind of drop the dust. But and now that's both for European style fabric belt with longitudinal groove top cover with lacing, or with a semi-elastic belt that is made endless. The raised rib, longitudinal rib, is a very, very good design change for where they're having slippage of their totes.
Great. Okay, last question, and then we'll wrap up for today. Why isn't steel cord used?
Well, the only thing I can tell you is the flex ratio on Kevlar for minimum pulley is better than using the piano wire design. The other thing is with Kevlar cord, if you look at it and you see how it's made, it's actually twisted several cords together. And what that does is it allows you to treat that cord with chemicals that will penetrate the cord and actually grip the urethane. You can't do that with steel cord. It's not porous, and the Kevlar is. So it gives you the ability to be able to treat the belt to give you a higher adhesion at the splice area.
And I was talking to an OEM actually last week who previously, about a year or two ago, on a live roller drive system they were developing, tried a steel corded belt. And basically, very quickly, what happened is the steel cord pulled out of the belt altogether.
Yeah.
And of course, once you have a steel cord wrapping around the system, it's not pretty.
No.
Awesome. Well, Rob and Kim, just want to thank you guys again for your time and your knowledge, sharing with the community. I think this was excellent. And, you know, like I mentioned at the beginning, we're going to record this and post it to our website for anyone who maybe wants to watch again from the beginning. The last thing I'll say before we sign off, just want to let everyone know that NIBA does host technical seminars, and we're hoping to do some of those in-person seminars in the fall based on how COVID develops. And some of those seminars include the lightweight splice school, heavyweight splice school, track train and troubleshoot, and key principles and best practice of lightweight belting. So I wanted to mention that because I think some of the questions that came in, it would be good to maybe expand upon that knowledge in an in-person. But that being said, any final words, guys, before we sign off?
No, I just want to thank everyone, including management at NIBA and those in attendance on this, for sharing information like this. It's invaluable. I think it's something that we all need to focus on whenever we have any opportunity to learn about industry. And NIBA is the best platform to do that I've known. 33 years in the industry. I've been going to NIBA for 33 years. So I think it's a great organization. I want to thank you again for this opportunity.
Yeah, just thank you very much, everybody, for your time.
Awesome. A lot of positive comments coming in too, guys. Great job. Thank yous. And yeah, hopefully we'll see you in person in September.
You will.
All right, everyone. Have a good rest of your day. Thank you again.
We thank you.
Thank you.
Bye.